Good morning. I hope the morning is doing good for you. Mornings are never good for me. So, I thought I would not be late. I was late anyway. It's like kind of thing that anyway happens. So anyway, we're here. I didn't think of bringing my sports stuff, but I'm like sweating all, and it would have been a good idea. So, the ScalaIO sent me an email like, oh, we need a title. I was like, oh, a title. And I didn't think enough about it. And I like, to keep my slides until the last moment so that I can think all the possible times so that I have like my freshest idea included in the slides. But I was constrained by this title. I thought, hey, we can change anything, right? So I thought, like, what would be a better title? I didn't like this title anyway, right? It doesn't explain anything. Like, I played or whatever thing is inside. I thought it's not cool, right? So what is exactly, I was thinking, like, what is exactly the title would be for such a keynote? And I thought, like, this is a cooler one. So, pure journey of changing physics to make problems disappear. Whoa. That sounds more like cooler, right? Yeah, it explains pretty much what we're doing in a sense, in an abstract way, and I tend to think in these kind of terms. So the most fascinating thing of aspect of software, we have no physics. We have no physics on software, almost not. I mean, of course, you have CPU, this, but even this tends to change every year, every month. So there's no constant physics. Constant laws of physics. Everything changes. Of course, you can be scared. You say, oh, I'm going to stop the world. I'm trying to define things because I don't want things to change. But also, you can say, like, I can get advantage of that. No, it's kind of cool, physics that change and that you can change yourself, right? Like, imagine now, if I want to fly, and everyone wants to fly. Who doesn't want to fly? And if you can go into the code of the universe, and just patch the code in that part to say, like, if it's me, then no gravity. Okay, and you tell the system that, and suddenly no gravity, you can move as fast as you want. Kind of cool, right? Oh, by the way, this is my fingerprints in whatever it is. So, but unfortunately, the universe is not open source. Its code is obfuscated and not documented, but we're doing some reverse engineering and all of that, and at some point, maybe we'll be having this luxury of hacking into that code. But I like to fly anyway. So, changing physics can change rules, and changing rules make problems disappear altogether, right? That's pretty nice. So, I was looking at the schedule, and I was like, oh, we're spending so much time trying to verify that current rules apply. That's a waste of time, right? I mean, it's interesting, right? It's interesting to be able to verify something, but you should have some balance, right, between creating new rules and verifying them. And by verifying, I'm talking about tests, I'm talking about types. It's very good, but just not. We need to have some kind of balance. We need to be able to change the rules. And change the rules, of course, as engineers will understand, like refactoring, redefining architecture, moving parts. Like we should be able to move things around. We should not put too much heavy constraints that stops us from changing the rules at any given day. Like imagine I have a new problem, a huge problem. I'm working on a startup, suddenly there's something that I need to take care of because it wasn't the business in the beginning, but it seems a very good opportunity. Well, if I have made all protections around to make sure that nothing changed, but this change will take a lot of time, right? And I'm not talking about like using dynamic or versus, this is not the discussion. We need to have a balance, like we need to talk about how can we verify correctness of things, but also we should talk about how can we change things, physics, change completely the laws of how our software is running. Because if you look at software, like even you look at programming language, you got like functional programming or with imperative or whatever, OOP or things like that. And if you can have these two completely strange programming languages, like they don't have much in common. still live on the same kind of infrastructure. It means that you can do anything, you can imagine anything, right? And we should be able to focus on also changing things as well as verifying things. Of course, half of the room lives here. And I would ask you, like, I had to do this kind of decision, you know, like, let's choose, I want to choose my camp. Where do I belong to? Do I belong to the kind of verification place, or the place where we should break rules, right? And it's very much like, you know, a Swiss watch, where they spend years and years into getting the most details, the most precise design, so that you don't have, you can get like to, I don't know how many seconds per year kind of confidence on time. And suddenly, a piece of hardware that doesn't even cost 5 or 10 or I don't know, like a couple of dollars, $100 maybe, I don't know what. It has atomic clock inside. It broke the rules. Like suddenly, the other thing is obsolete, and now you have enough precision for your practical life with something that was much less engineering, much less precision and verification. So I guess I would like to be on the left. Of course, again, I have to say that we're going to say ScalaIO and all of that. Types, verification, all of that is good, but it's a matter of balance. So, and what I like to do is, the way I define my work, my own work, the way I like to, I mean, I should understand, like, this many years after starting software, is that what I really like about our profession is that we are magicians. We really are magicians. I mean, imagine you can have something and then suddenly change the rules, things disappear, things change, start behaving completely differently. And this is your power. I mean, you look at someone like if they're having some problem and suddenly you type a couple of characters, you call it a script, and suddenly the script will make things disappear. That's magic, right? And that's what we're good at. It's magic. And this is what we call sometimes architecture. Well, exactly. I like to call it like magic. We kind of, you know, move things around, not to solve problems, to make problems disappear. Like you have like 10 problems, suddenly you say, like, okay, I'm moving this around and doing this, and suddenly 10 problems are not there anymore. They disappear. Okay? Of course, you're going to maybe to be disappointed. No types here. No tools, I'm not going to talk about any of these, no framers, nothing of that. Okay? So, half of the room leaves. So, I'm Sadek Drobi, I work for Singularity, and I co-created the Play framework with Guillaume. He was supposed to be here with me, had something in the morning, he'll be joining later on. And also, we founded Prismic.io. Who knows what Prismic.io is? Okay, maybe let's say 30 or 40%. Okay, so here's a quick tour on Prismic.io because we needed a bit for context, right? So Prismic.io. So Prismic.io is solving a problem. So we were like, you know, designing with Play framework and all that, and suddenly it was like getting a momentum, and we're seeing that succeeding. We thought like, hey, there's this other problem we want to solve. And we want to take our time to solve it because we had a lot of ideas, and that's why we got to talk with TypeSafe. We wanted to play to live for long. We wanted to hand it to good hands, and that's what TypeSafe did. And we wanted to take our time to think about another problem that's very annoying in today's work. Actually, I don't like being standing all the time, so I like to move. So. So we thought about okay, each time we have to build a website with some dynamic content. So let's imagine, we had to build the Play framework website, and suddenly there's some content inside, and then there's typos and these kind of things, rephrasing. And each time you have to do that, you have to redeploy because content is in code, right? So as you see in the first image. Everything is mixed up, and when we have to each time to redeploy the whole code and all of that. Of course, we're agile. We can deploy in a minute or something. But this is annoying, right? You need to fix the typos and deploy everything. And then we thought so this is one way of doing it. The other way of doing it is to use visual click-based tools, which means as a non-designer, I want to be able to build my website. And then you get these kind of blocks, you throw them at the screen, and suddenly you have a design that looks like, it suddenly looks like the 90s, right? Because, you know, that's how it looks like. And then you would like say, I want to integrate some more text here, and suddenly the thing breaks up completely. So that's another way of solving the problem. It doesn't seem to be the right problem. And then there is the plugin-oriented kind of software, right? The plugin-oriented software, which is, you know, CMS, which is like I get plugins, in my code I throw plugins in there, and it's not for developers, and it's not for designers, and it's not for writers. It's for no one actually. So developers will be frustrated, writers will be frustrated, everyone is frustrated. So that's the worst of every solution. And we thought, like, this is an easy problem. Like, we know everyone here knows how to solve this kind of problem. Why didn't anyone think of solving it? So what is the solution? Well, obviously, there are two things actually living here. Okay? There's content. Okay? Content is what you see on the website, all the text, images, and all these kind of things. And there is code. And they don't mix up. There are two different things. So basically, if you extract from the website, extract all the content and you put it somewhere, you call it document, you call it whatever you want, and then in your code, you just insert that content, you call some API, and you insert that content into your code, well, you're pretty much done. Because the developer will be able to use whatever technology he wants, PHP, Ruby, Scala, or what did I say? Scala, or Scala, or maybe Scala as well. And this is the marketing thing, I said PHP. Well. So, and with the API, you can pull the content, and then the writer doesn't have to look into that code. The writer has to modify documents in there, and suddenly they get published in your code, right? No deployment, nothing, right? Obvious, right? Basically, all what I'm saying here is we get the database, and then we pull from the database, we pull content, and we display. Except that, of course, we'll have with this database a lot of tools that will help writers, authoring code, publishing it, experimenting with it, and so on. So that's what Prismic.io is. What we call a writing room, okay? And this is where the content lives, this is where it evolves, where you publish, all these kind of things. And an API that will help any developer in any technology to pull that content and throw it in any design, application, language, whatever you want. Okay? Is it clear? No? Yes. Okay, that's better. Mornings are hard, I know. Yes. So, and at Prismic.io, we make problems disappear. That's how I like it. Each time I get it's annoying, we have all users, what can we do? And let's make it disappear. Let's make the whole problem altogether disappear. And what I want to show is a few examples of how architecture can magically change everything. Physics, change physics. You go in the physics and say the physics are now different, and suddenly, no problem. So this is the first problem we encountered. We started Prismic.io and we thought this annoying problem is that we have in the writing room, so there are a lot of writers that will be writing content and adding images and so on and so on. And it's pretty much highly dynamic and versatile. So you can't ask writers stop writing now because we're doing something, right? They need to be able to write all the time, and it's dynamic. But from the website side, the website should be always consistent and highly available. Basically, I can tell. So imagine if a service like Prismic.io goes down, every single website that uses it will go down. Of course, we provide guarantees on caching and these kind of things. But it's pretty annoying, right? To ask someone that uses your service, please use some caching because we can go down. It's not a good story, right? We didn't want to talk about these stories. We'll design for that, but we want to be always up. Now, how can we do that? It's kind of annoying. We have from one side a system that needs to be dynamic, and from the other side it needs to be available and consistent. And then someone will say you can use clustering and sharding and blah blah blah, other buzzwords. But I don't know. DevOps and I was Like this is, it seems like, I don't know, I don't understand these kind of things. I understand my problem. This is a good thing. Like, you know, try to understand your domain problem. Like, I really understand my problem, what my problem is. I can design myself the physics so that it works as I want. And if we looked at it, like there's this huge database, and then there is these two different things, the website that's pulling content and the writing room. And actually, it's very obvious, and I guess any one of you would have like coded, is that there are two different time spaces. Means like two different times. They're not linked. Every system of these two has its own time, right? So we had the writing room where like writers should see something, but then the website, there are different users, different people viewing different things, right? And if we separate this system into two times, okay, just by simply separating this system into two systems, we made problems disappear. Meaning that, so here's the writing universe. We separate it into two universes. This is writing universe, and you don't see anything from this slide, but just let me explain it anyway. So we have some writer who's writing some content, and at some point he says like, I want to publish now this what I wrote. Okay? Now this is the tunnel between the two universes. This is where we get this content that was that the writer is willing to publish, and then we transform it into the other universe now, right? And then it starts living in the other universe. Well, basically, more concretely, anytime someone publishes something, we zip this content, let's call it a snapshot of the content, and we send it to the other universe. And that universe then will be able to deploy it, and since it's a zip, it's a static content, it's extremely scalable. Like you can just spawn machines as you want, and deploy these zips, and suddenly you can have like as many as you want of machines serving this content. So, but by just this very small, tiny decision, you made several things disappear. So you get a scalable, high available, and consistent API, and a safe writing room. So one of the problems of CMSs today is that publishers are extremely scared to touch anything. Like, oh, will it be published? Am I breaking the website? We don't have it anymore. There's no link between these two times, right? The two systems, except the publish button. If you don't press on that button, nothing can go wrong. Impossible, right? So we solve the problem from the fundamentals, right? And this is what I like about like our profession. Problem number two. So we have we didn't solve the problem completely. So this kind of solves part of the problem. The other part of the problem is we have writers, right? They are writing, and suddenly someone says like, "Oh, I want to publish." Like, what is the intention of this person? What is he intending to do? So imagine there are three people that are publishing, like that writing content, and suddenly there's a fourth that says, "I want to publish." What is he publishing exactly? Is he publishing what is being written right now? No. I mean, he doesn't know what's written. Maybe like some mistakes. Maybe someone is doing crap, and he will not be publishing this crap. He wants to publish what is he seeing. What he's seeing, right? He sees some documents, he sees some content, and he says like, "This is exactly what I want to publish." Okay? So that's annoying, right? How can I stop the word while we're publishing? Should I say like people, okay, we're locking everything down because someone is publishing, you can't write, you can't say nothing you can do. It's pretty annoying, right? Locks, and who knows about locks in source versioning, what's a Microsoft product? Anyway, we developers don't like this kind of workflows and collaboration. So, as I said, someone is improving the homepage, the second is working on something else, and the third, and there's the fourth that is publishing. I don't want to use logs in here. You want to solve the problem, fundamentally. And I guess, again, most of you would have solved it exactly in the same way we solved it. We use Git, right? So everything is immutable. Now, if I tell a user, anytime you make a change, it's a new version, so you'll be only creating new version. You will not be messing with other documents or changes. So I will make changes, and then I will say all these versions I want to publish them. Can they change in the while I'm publishing? No, they're immutable, right? And just by taking this decision of making the history of the document completely immutable, then we could solve this consistency problem, right? Because again, if I'm looking at a couple of documents I want to publish, they can't change. And then I hit the publish button, and then they go publish. If there are new versions that are being written, it doesn't matter. What I decide is what I see, and this is my intention. And again, by connecting to the domain problem, you can understand what are the things, like what exactly you want to achieve, and then you achieve it in the architecture. Okay? So, what did we solve? Well, no destructive conflicts. You can go into conflicts, right? Everyone is creating a new version. And if there's a conflict, well, I have my version, you have your version. Nothing disappears here. Nothing can go wrong. I mean, at some point we have to merge maybe, but we don't lose anything by merging. We still have both versions. They are immutable. They live forever. And actually, in Prismic, we keep them forever. You never lose a change. All versions are kept forever. Publishing is consistent, right? As I explained. You can undo any time. You have every single version you ever did. If something goes wrong, if you publish the wrong document, or you get this oops moment, well, go ahead and publish an older version. Everything exists. Actually, all of us, we know how this works, right? We use Git and we know how it's comfortable, how confident we are to publish something, because we know like at any time we can go back. There's no stress, right? And I don't know if some of you work in the CMS space. It's a huge stress. Or I need to make it proofread by 10 people so that nothing goes on, because otherwise I will be fired. You know, it's the public website. People will see it and I will be fired. Well, I hope no one fires someone first. I heard stories. And guess what? This is the most interesting thing. I mean, we are a bit. I mean, let me. I have to say that we are a bit selfish as developers. We're really selfish. I mean, we have so many good tools, and we never share them with other people, other professions, right? We have this luxury of having, of course, with Git and other tools, is that we can have, we call it branches, as many branches as we can. I can work on different branches, and they have different stories. But we don't share them with like, for instance, content writers. And with Git, this kind of architecture, well, that's what they get. If someone is working on the home page and they have like 10 changes to do, and someone else is working on a new release of a new product, let's say there's a company that releases a new product. These are two different things, right? They're working on completely two different change sets. And there's maybe a third that he's updating for an event that will happen in December. 3 different things. So we have different branches. Why? Because everything's immutable. We can branch as many times as we want. So we can have different teams working on different things in the same time, and that doesn't cause any problem. Nothing. Of course, whenever you publish one, it will update the others if you want, what we call rebase, and all these kind of things, right? And of course, another thing that is interesting, whenever you can do these kind of different environments, then you can do something with what we call experiment variation, which means like you can have like maybe 10 variations of the home page, of the content of the home page, and then test do some kind of A/B testing, that we call it multivariant testing, to see which variation is the best. Why? Because you can have different releases, different branches in the same time, and you test which one is best, and then you publish it. And all of that because we took this kind of architectural decision to organize these things in different ways. And if you want to go to the next slide, I promise the next slide. What is I now? Is it a joke? Oh shit. Seriously? Okay. Please don't look at my password.
1, 2, 3, 4, 5, 6.
Oh, he guessed it. I'm going to change it. Oh, let's start from the beginning. Oh, I have no idea where I was. That's what happened. Okay, so another problem we wanted to solve is that we're kind of Prismic.io is some kind of like it's a startup, right? And you're expecting like, hey, one day I'll have this kind of I mean, you watch users, you watch people that are creating new accounts, and say like, oh, it's going fast now, right? You're kind of anxious. Is it going to go wrong? Like, will I be able to handle so many users? I don't know. First, like we stored things in a huge database, and we're like, okay, let's cross fingers that this database will be supporting these kind of things, and then we ask around, so like, okay, let's go. You can do clustering at some point, like you can same things with stuff like scale, clustering, and like or sharding, and then sharding is not scale, and then you said, okay, I want some solution not to worry anymore about this. I should be happy, right? Anytime like I get more users, I should be happy, and I should not be worrying. And this is worrying, right? If someone is saying, I hope I'm not getting any users because I'm not sure about my architecture. You should be happy about like getting more users, and you should be proud of it. No problem. So we wanted to store like no matter how many users we get, we want to be able to absorb that. Well, actually, even better. What we wanted to do, we had this kind of thing in Prismic.io, is that you first of all you have while you're developing, okay, you're not paying. As long as you're doing your application, you're not paying. Now that it means like you will be storing stuff. You'll be using machines, memory, all these kind of things, but you're not paying because your application is not in production. Not only that, you can have as many repositories as you want while developing, and you can have this kind of what we call the example repository. You can fork it as well, which means that you can have also. So you can have it can go wild with storage, right? And CPU and memory usage and all of these kind of things. And we didn't want to worry about that. We even wanted to, and that's what we did, is to make it even free for open content and open source. Now to be able to do these kind of decisions, you can't just blindly say like, oh, it's open, and then suddenly everything crashes. And you need to take decisions to guarantee that when you're introducing these kind of things, everything will work. Okay, and of course not to ruin the whole company because you're getting more users. You need to have it efficient, like cost effective. Okay, so we thought about let's kind of see how people work on this on Prismic.io repositories, and then we were observing. So like there's some person like he uses like 2 hours each day to update some news. The other once a week for a blog post. The third like maybe will not open it once a month, and the third he opens it once and that's it. Maybe he will not open it in the coming 6 months. I mean, there are different people. They do different things, right? And the wrong thing here will be is to couple all these people with the same time. You tell them like all of you live in the same kind of environment, in the same universe. Now we thought like about what about like giving them different times, different databases. Okay? So every user gets his own database. Okay? Own time, own database. Okay? That means that the first user, if he uses 2 hours a day, okay, and the second like once a week or something, well, between these 2 times, his time doesn't tick, doesn't exist, right? His system doesn't move at all. No one connected, no one did any actions. If you look at the history between, let's say, day 1 and day 7, nothing happened. Time didn't tick. There's no time between these 2 instances. So we could, by providing different times, we could stop times. Okay? So one repository, it will have its time paused, stopped, until there's someone else that's coming. And that's interesting. When time stops, what happens? If now time stops, we don't exist, right? We disappear. Time doesn't exist. Time stops. Okay? And if time stops, why would I be having this around, right? If this first repository, it stops to exist because it doesn't have time, well, I can archive it. I don't have to keep it around. Which simply means I can maybe have only the one in the middle because now it has time, but the others don't have time, and I can completely erase them. They will not use any CPU, no memory, nothing. They don't exist. Okay, they don't use my infrastructure. They don't have to use it, right? So, a simple decision, architecture decision, means that I can archive any repository at any time, and whenever someone comes, well, I will go grab it, like unzip it, and then that's it. Now time's rolling. Whenever that is inactive, okay, I can zip it, I can archive it, and it doesn't exist anymore. What does it mean? It means we can have millions of repositories, but having 100 only working at the same time. Right? And when the repositories don't exist, they don't even exist in the database. They exist nowhere. They exist in maybe S3 or some storage, kind of very cheap storage service. And that's all where their existence is. But in my system, they don't exist. They don't consume anything. And that's how we get like this extremely scalable and extremely cost-efficient architecture and platform. I mean, today, the last of our worries is how much space things are taking. We don't even care about it. Like that's how we could like announce like, okay, it's open for open source, it's for free for open content, and all these kind of things. Because there's something behind. Something like we took the decision to make things. So basically, here what goes actually is at some time, if we want, if we see our platform is busy, then we could say, okay, now here I'm going to archive anything that is not active now, and then it's a matter of a second or two to bring it back to life. Okay, anytime it's time posed, I can clean it if I want. If I don't need you, I don't need to. If like there's no need for that, I can keep it, but I can also archive it. Whenever someone gets like with a request to it, I can grab it, deploy it, and it's running. Okay, so that solves very much our problem, but it's even better. It solves a lot of other problems. First, as I told, it makes all these problems disappear. Scalable. I don't care about space. I don't care about CPU. I don't care about all these kind of things, right? The other thing is that here's one very annoying thing about SaaS platforms. That we host data, right? And if a developer chooses to make some modification in the data format, it means I have to migrate the whole database. You know, migration might take like, I don't know, like a few minutes or maybe 30 minutes or something like that. It depends how huge the thing is. And anytime you need to migrate, normally you'll close the word. No one should update while I'm migrating. Like means all writers should stop working. Anyone working on the platform should stop working while we're migrating. It means we should really be careful about not deploying stuff with that change data. And this is not what we want. We're a startup. We want to experiment with things. We want to introduce new things. We don't want to have this kind of fear. Now by separating times, now I have some data migration, and then I see Nicola that connects to his repository. I say, oh, okay, I'm going to migrate your repository, but I have to do that. And then it takes like seconds, and he's running. Maybe I didn't migrate the others. Maybe I'm trying to migrate the other in the background. But I don't care about like stopping the word, locking everything, and doing that. I can migrate one repository at a time, and that's okay. Okay, for a new data format. And even if there are some inactive repository I didn't migrate, it doesn't matter. I mean, when they connect, I know that I have to migrate them, right? And another problem is that I can have multi-production environments. And this is something we really like to do. I mean, we introduce new features, right? And new features break things. But we don't care. Why? Because, you know, we have these separate environments. We have production, we have experiment, we have stage, we can have as many environments as we want. And it's not about like machines, it's about like just putting the repository on the right cluster, right? So we have this reverse proxy that will decide, like, this repository, where does it go? It goes into stable, it goes into experiment, it goes into this kind of new feature, and so on and so on. Which means, like, when we introduce, so we thought like about how can we get the quality of our platform much higher than what is it like, than standards. Well, it's very simple. You do real world testing. So anytime you introduce, like for instance, now we're introducing experiments, Prismic IO experiments, which is like multivariant testing variations for content, and we deploy it in one environment. And then we ask, if anyone wants to test it, you can test it with your repo or a test repo, you tell it. And whenever someone says, I want to do that, we route it into this kind of experiment environment. If something goes wrong, we have all the history to get it back to the stable one, nothing happened. Okay? So this is how we do it. Anytime we introduce a new feature, we migrate slowly people into that. It can take a day or it can take a week, so that we are sure that we're not introducing any big problem, right? And this is extremely comfortable. So our development team is just experimenting with things, like no fear, and then we know how to test things in the long term. Of course, some bugs can escape, but still, it's a much better process, right? You can go into different environments and you get that testing. Okay? And exactly, this is like just by taking this small decision, it's a bunch of problems that just disappear, right? They don't exist anymore. We change the physics of things. Yeah. So like something else we wanted to solve, like caching, right? Very annoying, right? We have an API. A website depend on this. A website can't display any of it, can't appear until it gets content from Prismic IO. So imagine you have Playframe or whatever, like Prismic IO website or any other website. It will like be nothing, and we'll do like maybe 10 calls or more to Prismic IO and suddenly everything. Now, we can be extremely performant, and we are today. Still, there's going and back, going and forth with the network, and that's delays, right? And if every time you have to go fetch something, go back and then fetch another thing, and then you do like 20 calls, your website is going to suffer. And of course, for that we have caching. But now, how can we do caching? Like, can I say like, okay, come back in 10 minutes? 10 minutes, is it enough? Is it enough? Like, it means like someone should fetch every 10 minutes? And hey, it's even worse. Like, it means when someone publishes something, he should wait 10 minutes until he sees that he's changed it. Pretty annoying, right? You publish, you go take a coffee, talk to your colleagues, and they say, oh, I did the typo, I should publish again, and so on. Like, it's completely unacceptable. You have to solve this problem. You don't have to tell your users like, go find yourself a solution. We have to solve it, right? So how can we solve that? We want the two opposites, right? Extreme cache performance, yet like instantaneously displaying updates. So how can we do about that? Who knows what RESTful API is? Let's see. I will ask that question after. So RESTful API. What is RESTful API? RESTful API is a very simple thing. You can imagine a RESTful API as a website. An ugly one, of course, because you don't have time and all that. But what is the RESTful API? You go, one URL. You go into that URL, and then it displays things. Okay? It's a response. But it has inside links, it has forms. You can submit. And then you go into another step. And from that steps, you have other links, other forms, and so on and so on. Right? This is what RESTful API is. Anytime someone sells you RESTful API as a bunch of endpoints, they're lying. Okay? RESTful API is a one endpoint, exactly one endpoint, to which you send a request, you get an answer, and then the machine will try to understand this answer, and then to do some requests afterwards. And this kind of architecture was extremely interesting for our case, because the first URL you'll be calling is /API. So this is the only endpoint that exists with Prismic IO. /API. And /API will tell you, hey, what you can do is you can search for a document using this form, and you can search for other kind of documents using these forms, and here are links for doing this and this and that. Okay? Now, anytime, so it has definitions for forms, exactly like the forms that you see on normal websites. It has forms. And then the code would be like reading the form, understanding it, and then submitting it using the right action URL and so on and so on. Now the trick here is that I can change this URL the way I want, right? Because you don't have it. You read the /API for getting it, right? You tell, hey, /API, what have you got? I tell you, like, if you want to submit searches for this document, use this form. Say, okay, what's the URL I have to submit to? And you have a URL. And this URL, you don't keep it. Each time you ask again for this URL. Now, if I include the version of the content in this URL, you don't have to worry about that. But just you tell me, what should I do? And then I get you the version of the URL, the version of the content in this URL. It means anytime there's a new change, I can change this URL. It means that your cache, is invalidated automatically. Which means you can cache documents forever. Like at your side, go ahead, cache your documents forever. You don't care, right? Because documents do not change; they are immutable. Searches don't change. Okay? Once you get a search, you can save it forever. If you don't have a new URL, that's fine, you can keep it. Now this property is extremely interesting in this kind of cloud platform. It means your website doesn't even need to talk to Prismic.io. After it gets its content the first time, that's it, done. Like done forever. So instead of architecture will say, let's do some kind of webhooks that will notify the user, so the user can clear some cache, and then you have this kind of, this is extremely complex. By using the RESTful architecture and doing these small tricks, okay, you get the cache forever semantics, yet updates happen right away. Okay, so you publish, you go to the website, you have the changes. In the meantime, everything is cached. And this is exactly what the property that there are a lot of users that are appreciating, because they can statically generate websites. Like, even if we take that, and we don't want it, we want it never to happen. But even if Prismic.io API goes down, and we did everything not to happen, if it goes down, don't even care. You call /API, it's not there, I don't care. I take the last one, and then I have all the caching. Because you have very clear, very simple caching semantics. And these caching semantics allow you to be confident about, okay, I should not check about caching or anything. If the ref didn't change, nothing changes, I can go ahead and continue work. Okay? So in this kind of environment, we try to innovate in this kind of word, in the CMS world, like a very kind of obsolete, with around you obsolete tools. You need to use innovation to solve real problems. We did this separation, and we created problems with this kind of separation. We solved some, but we created others. We had to use to change rules to be able to bridge back these kind of two things, and you use architecture tricks to be able to solve these kind of very annoying problems, to get these kind of very interesting properties in our system. Okay? So this explains exactly what I did. I get the /API, and it gives me a form, and then I submit to that form because it has an action link, and if it changes, it invalidates the cache, and that's what gets us this kind of extreme cache. And that works very well with CNs, with reverse proxies, extremely friendly for these kind of things, right? Because there's no delays, nothing like that. Okay. So I think I have to admit it. I'm a very lazy person. Really, I am. I mean, maybe you guessed it by the fact that I was late today this morning, and I really apologize for that. I couldn't fix my stuff. I'm originally from Syria, and maybe it comes really genetically from there. I don't know. I have to check on that. So I'm very lazy. And it seemed I'm a very, very little kid. It looked so awesome when you can do this small thing and suddenly things happen, right? You don't have to do 10 things. You do one simple thing, and then 10 things get solved. When you're lazy, you like these kind of things. And it seems to me very much like magic, right? It's true magic. Actually, it is true magic. The magician, you see on the stage, he will be trying to hide reality. We don't hide reality. We redefine reality. We kind of change the rules so the reality changes, and it changes really profoundly. And I guess this is the most interesting property of our industry, of our profession. We have very few rules, and even these rules change. Who would have said that this is not a problem, this space is not a problem? Who would have ever said that The number of cores on a machine is not a problem anymore. We didn't know that, and this changes all the time. And I tend to like it, and I tend to like finding these little tricks, you know, and they're very deep in the software that will make things vanish. You know why? Because then I can spend my week doing nothing. I mean, someone assigns me like 10 things. Okay, 10 things I have to do. Let's find an idea that solves them all together. And in the week, I'm on Twitter. I can spend my time doing something else. And that's why we love architecture. And this is exactly what we do all the time at Prismic. This is why I love working at Prismic. And this is what you should love about your profession, software engineering. You know, if you look at the basics, very basics of computer science, what is it about? It's about algorithms. Algorithms are scripts. Like imagine you can tell someone like I can count the number of people in here in 1 second because I have a trick to do that. How awesome is that? Like, you know, sorting lists. Instead of like sorting two elements, like you have things to cut into two, and then you sort small things and suddenly everything is sorted. It's like algorithms are scripts. Are scripts to do magic on data, right? Do magic on data, magic on hard problems. So I really hope that you get this kind of idea that, you know, let's spend enough time also on challenging rules, on challenging basic rules about our architecture. Let's make our architecture responsive to these kind of changes, because these changes, you know, architecture is not about defining some structure that never moves. It's about changing architecture. It's not, so the word architecture is really misleading, and that's why I don't like it. Man, architecture is like about a building, and building it means like we should do these kind of basic things that never move. Okay, and that's not. I don't like it this way. I want to do architecture that moves, you know, and that's rather I want to define realities that are still very, you know, kind of you can, you know, changeable anytime you want. Okay, that's all for what I wanted to say for today. I hope I was clear enough. I hope you like the idea. I hope you have, like, you know, you have projects where you can do these kind of changes. And again, sorry for being late. And that's it for today.